All right, in this video, we're going to talk about how to teach graphing secant and cosecant. I have other videos on graphing the cotangent and the tangent, and also the sine and the cosine. So this process will be the same as those two videos, and I'll put a link to those videos here wherever you're watching this one. The first thing is that students need to be familiar with what the parent graph of the cosecant function looks like, which is based on the sine curve, since the cosecant is reciprocal of the sine curve. So I would graph the trig function, the sine function here, and you want to look at some key points here. For example, everywhere that the sine function crosses the x-axis, the cosecant function is going to have a vertical asymptote. And then looking at like pi over 2 comma 1 or 3 pi over 2 negative 1, you want to do the reciprocal of that y value. Well, the reciprocal of 1 is still 1, the reciprocal of negative 1 is still negative 1. But then when you look at something like this is the point pi over 6 comma a half, and then the reciprocal of a half is going to be 2, so that point's going to be put up there. There's going to be another one over here, 5 pi over 6 comma 2, and then here this is the point 7 pi over 6 negative a half, which is going to be reciprocal down here at negative 2, and so on. So then you connect the points, and the students get the idea that you're going to have these sort of U-shaped functions. They always want to call it a parabola, but it's not technically a parabola, but they do look like parabolas. You've got one that's going up and one that's going down. And so here's the graph on its own without the sine function, but we're going to use the sine function to sort of help us graph the cosecant function. And then here we'll do the same thing for the secant function. We're going to use a graph of the cosine function. Here's your cosine function. Again, everywhere that the cosine function passes the x-axis, we're going to have a vertical asymptote. And then it's the same kind of idea that where you have this sort of upside down, or sorry, this sort of U shape here between pi over 2 and 3 pi over 2. You're going to get your upside down U shape there approaching those asymptotes. And then here you're going to have like half of that curve that's going to get flipped around like so. So if you were to continue it, it would look like that. And then this half part here gets flipped around like so. So this is the this is the secant function by itself. One complete cycle of it I'm just going to scratch this stuff out over here. So one cycle of the secant function, you're going to have this sort of half U, this sort of U shape, and then this sort of half bit here. Okay. The steps for graphing would be to analyze their reciprocal function. So if it's a cosine, then if it's a cosecant, you're going to analyze the sine. And if it's the secant, you're going to analyze the cosine. You're going to talk about the vertical horizontal dilation, any kind of reflection, or any kind of, I should say, translation, so transformation. And then you're going to make a t-table for that reciprocal function, whether it be sine or cosine. Identify those vertical asymptotes. That's going to be where the sine of the cosine would cross its midline. And then plot your asymptotes and other points in the t-table to sketch the graph. So let's get started. And again, if you haven't yet watched the video on how I teach graphing sine and cosine, start with that and then come back to this video. So we're looking at the graph of 2 times the cosecant of x plus pi over 4. Let's start with some analysis of this particular function. So for example, we're going to have a vertical stretch by a factor of 2. And also I see that we're going to have a phase shift or a horizontal shift. We're going left pi over 4. We don't have any changes to the period, so there's not going to be any kind of a horizontal. And if they ask for the period, of course the period is going to be 2 pi. But that means you're going to have no change to the parent graph. And then also you're going to have no vertical shift. So that also means you're not going to have any change to the parent graph there. So next I would make a t-table for that parent graph. So the parent graph for cosecant is going to be the sine function. So I'm going to make a t-table for sine function. If you want, you can make like another column here. So if you want, you can make another column here. And we know that, for example, the cosecant function, that's where we're going to have your asymptote at 0, your asymptote, and your asymptote there. But that's not what we're trying to graph. We're trying to graph this transformed function. So I'm going to make another t-table. So we have a vertical stretch by 2. So that's going to affect the y-coordinates. So that means we're going to multiply the y's by 2. And then the phase shift left pi over 4 means we're going to subtract pi over 4 from the x's. And then of course there's no change to the period, which would be the horizontal stretch or shrink, and there's no change to a vertical shift. So all I really need to do is multiply the y's by 2 and then subtract pi over 4 from the x's. Let's start with multiplying the y's by 2 because that'll be pretty easy. So multiplying all these by 2, we're going to end up with 0, 2, 0, negative 2, 0. But again, that's where you're going to have your asymptotes. And then we're going to take pi, our x coordinates here, we're going to subtract pi over 4. So 0 minus pi over 4 will be negative pi over 4. Pi over 2 minus pi over 4, that's like a half minus a fourth, which is going to be a fourth. Pi minus pi over 4, that's going to be 3 pi over 4. And then 3 pi over 2 minus pi over 4, common denominator is 6 pi over 4 minus pi over 4. So that's going to be 5 pi over 4. And then 2 pi minus pi over 4, 7 pi over 4. All right, now all we have left to do then is to make our grid and plot some points. So I see that my x-axis I have to show negative pi over 4 and 7 pi over 4. So I'm probably going to make tick marks to go every pi over 4. I'm going to have negative a fourth there, and then 1/4, 2/4, 3/4, 4/4, that's going to be pi. 5/4, 6/4, 7/4, 8/4, that's going to be 2 pi over there. And then, of course, that's negative pi over 4. And then for my y-axis, let's just do like a 1, 2, and a 1, 2. So you'll notice that I'm just doing this on blank paper. I don't have any kind of pre-printed grid lines. I don't have graph paper. And this is what I would do for my students. And sometimes my students might want some grid paper, some graph paper, and that's totally fine. What I've stopped doing is I've stopped giving the students the kind of graph paper where I just have a box and then I have a bunch of little tick marks here and tick marks here and tick marks here. Because what happens is that the students don't really know how to label their scale. So they might say, probably for this example, they would go, that's going to be pi over 4, and that's going to be 3 pi over 4. And I say, no, that's wrong, because they're saying the distance between this 0 and the first grid line or the tick mark is pi over 4, but the distance between the first grid line or tick mark or the second tick mark is pi over 2. And that's, your scale is off there, and then I penalize them for that. So you can avoid that penalty by just not giving them any kind of paper with grid line marks on it, to be honest. The students, I mean, they're still going to they would still mess up if they did that here. They need to recognize that if you're going to make the first grid line pi over 4, then you're counting by fourths of pi. Real good practice fraction work, honestly. So at negative pi over 4, we're going to have an asymptote. So asymptote here. We're going to have another asymptote at 3 pi over 4, so that's going to be here. And an asymptote is 7 pi over 4, so that's going to be there. And then we're going to have a point at pi over 4, 2, and at 5 pi over 4, comma, negative 2. So you'll notice that we're like halfway between these asymptotes is where we're going to have our little maximum point here, and halfway between these asymptotes is where we're going to have our minimum here. And it's always going to work out that way. And then we're going to make this sort of a U shape, and we're going to approach those asymptotes like so. And then sort of an upside down U shape, approach our asymptotes like so. And that's it. That's what I would expect my students to be able to do. All right, now we're going to do a secant function. Let's start by doing our analysis. We're going to have a vertical stretch. I would not call this at all an amplitude because the secant function does not have an amplitude. It has a vertical stretch to it. So I make it a point to never consider this the amplitude with a secant or a cosecant or a tangent or a cotangent. Oh, this one is wonky because we've got this x here. I don't like this. When I teach this, I always have them teach it with a pulled out side. So we'll go ahead and pull out that pi. So we're going to have pi and then x minus 1. And then that's all going to be in the secant. Then I can see that I'm going to have the period is going to be 2 pi divided by pi. This is different. That's just going to be 2. We'll come back to that in a minute. We're going to have a phase shift. This is also a little different than what we usually see. We're going to have a phase shift that's going to take us to the right 1. And we're going to have our vertical translation that's going to take us up 1. For the vertical stretch and the reflection in the x-axis, it basically means we're going to multiply the y's by negative 2. Now for the period being 2, that's essentially a horizontal shrink by pi. That's kind of wonky. What this means is that we are going to multiply the x's by 1 over pi. Seems like it's going to be confusing, but it's actually going to be a little easier when we get there. Phase shift right 1, that means we're going to add 1 to the x's because a phase shift is affecting it horizontally. And vertical translation up 1 means we're going to add 1 to the y's. So let's start with doing our t-table for the reciprocal function. In this case, it would be the cosine function. So there's the t-table for the parent function. Of course, here's where we're going to have our asymptote, but that's not the actual graph we want to plot. The graph we want to plot, it will be the secant function. And we're going to look at the t-table of the transformed values. We want to take the y's. We want to first multiply the y's by -2, and then we're going to add 1 to them. So we're taking these y values here from the parent graph. We're going to multiply them by -2 and then add 1 to them. So starting with 1 multiplied by -2 is -2. Add 1, it's going to be -1. And then 0, multiply that by -2, it's still going to be 0. Add 1, it's going to be 1. And then take the -1, multiply by -2, it's going to be +2 plus 1. That's going to be 3. All right. And then for the x's, we need to multiply the x's by 1 over pi and then add 1 to them. So let's take a look at the first one. So we're going to take 0 times 1 over pi and then add 1. Well, 0 times 1 over pi is going to be 0 plus 1. That's going to be 1. So the next one. Now we're going to take pi over 2 times 1 over pi plus 1. So look at that. The pi's become 1. So now we're looking at 1 plus 1/2, which is just 1.5. Next up, we're going to do it with pi times 1 over pi. That's just going to be 1 plus 1 is going to be 2. And then finally, we're going to do it with 2 pi. Whoops. So 2 pi times 1 over pi plus 1. That's going to be 2 plus 1, so 3. So it seemed really intimidating, but actually it turned out a lot nicer. We're going to set up our axes. So remember, this is where you're going to have your asymptote. And at 1 comma -1, we're going to have a point. And then at 2 comma 3, we're going to have a point. And at 3 comma -1, we're going to have a point. And so this is going to face upward like so, and this is going to go down there and face those asymptotes like so. Voila, and that's what I'm looking for. Now I'll tell you this, when I teach this to my students, this kind of errors that they make is they'll plot these points and then they do like a downward section here and then they do like an upward section here, and then of course that's totally the wrong graph. So if I were to grade this, it might be like for the scale, 1 point. And then for the asymptotes, 1 point. And then for the other plotted points, 1 point for that. And then for the shape, 1 point for that. So that would do 4 points for this, just for this section of it. If you also wanted them to make the t-table, maybe you make them a point or 2 points for them writing down the t-table. If you want them to write down all this analysis of the graph, it might be 2 to 4 points for this graph. You want to do like a half for each little bit there. So however it is that you want to count points for this particular question, I definitely would do 4 points just for the graph alone. Or I guess you can make each of these a half and just make the whole thing worth just 2 points, depending on how much weight you want this question to have on your assessment. All right, I hope you enjoyed the video.